Hello, today we are going to learn processes and system monitoring. You will learn what PID is, how processes appear in the system, how a process is different from a service, how to view running processes, how to understand what is putting load on the system, how to stop frozen programs, how to change process priority, and where to look if something is not working correctly in Linux. So, after this lesson, you will already have a basic set of commands that helps you not just use Linux, but really understand what is happening in the system right now. Let's start with the basics. When you start a program, a process appears in the system. So, a process is simply a running program. You open a terminal, this is a process. You run bash, python, top, or sleep. Those are also processes. Each process has its own number. This number is called PID, which means process ID. This is how the system knows which process it is working with. You can view processes, for example, like this. Each line here is a separate process, and one of the most important columns here is PID. So the simple idea is a process is something that is running, and PID it is identifier. Processes in Linux have a top level in the process tree. In modern distributions, this is usually system D, and it normally has PID 1. So processes in Linux are not just a random list of programs. They form a tree. One process can create other processes, and those can create their own child process. A new process usually does not appear by itself. Most of the time, it is created by another process that is already running. If we explain it in a very simple way, a process first creates almost a copy of itself. After that, a new process appears, and then it can start another program. That is why Linux has the ideas of parent and child process. A parent process is the one that creates a new process. A child process is the one that was created. Each process has its own PID, process ID. And there is also PID, parent's process ID, which is the ID of the parent process. So, PID is the number of the process itself. PID is the number of the processes that created it. Now, let's briefly talk about two special cases. A zombie process is a process that has already finished, but its record is still in the process table, because the parent process has not yet collected information about its exit. In simple words, the process is already done, but the system has not fully removed it yet. An orphan process is a case where the parent process has already finished, but the child process is still running. In that case, it is usually aborted by a system process, for example, system D. So the difference is simple. A zombie has already finished, but its record is still there. An orphan is still running, but its parent is already gone. You open the terminal. The terminal is already a process. Then inside the terminal you run a command, for example ls or top. At the moment the terminal creates a child process for that command. So here the terminal is the parent process and the command you started is the child process. This is the normal way processes appear in Linux. One process is already running. This is also useful to understand early. A process is simply something that is running. A service is usually a system service that works in the background and is managed through systemd. So a service is not something completely separate from a process. A service also works as a process or as several processes. The difference is that services are usually managed with systemctl. And here is the good practical rule. If the problem is with a service, it is better to first check its status, not command ps or top. For example, on the normal Ubuntu system, you can show it like this. Systemctl status systemd journalctl systemd journalctl. You see? Active. Everything work. Why is this useful? Because systemctl status shows right away whether the service is active or not. Here is active. Whether it started successfully, whether there are errors, and very often it also shows part of the latest logs. So if the problem is with a service, first check systemctl status and only then go further if needed. Let's go back to the command ps aux. This command shows the list of processes. Usually here people look at the user, PID, CPU usage, memory usage, and the command itself. But most of the time we do not need the full list, only something specific. For example, we can search for bash. I show same command and grep bash. You see, only bash. This is a very common method. We take the output of one command and filter it with grep. And one more thing, the output will also include grep itself. This is normal. You see, grep. For a beginner level, the main thing is to understand the idea. This aux shows processes, and grep help us quickly find the one we need. If you want to watch the system live in real time, you can use command top. Here it is convenient to see what is using the CPU, what is using memory, which processes are the most active right now. If PS is more like a snapshot of the system at one moment, then top is a live picture. Very often, when the system is slow, one of the first commands to use is stop. If a stop is installed, it is usually easier to read and more user-friendly. But there is one important point. Top is almost always already installed, but stop may not be installed. So you should definitely know top at least. Let's understand how to stop processes. The command kill doesn't always mean kill in the hard sense. It sends a signal to a process. The most common version is kill and PID. Kill number. By default, kill PID sends the term signal, which is a soft request to stop. You can also write it clearly. Kill -15 and here PID. Signal 15 or term tells the process, please stop in a normal way. So first we give a process a chance to exit cleanly. If that does not help, there is a harder option. Kill -9 PID. This is the kill signal. It stops the process by force. In very simple words, kill or kill -15 means soft stop. Kill -9 means hard stop. A good habit is this. First, try the normal stop and keep kill -9 as the last option. You can see other signals with command kill -L. Kill -L. Yeah. Kill -L. It's all signals. Sometimes it is important not only to see a process, but also to understand how aggressively it uses CPU resources. For that, we have nice and renice. It is very simple words. They affect process priority for CPU time. I show top and this nice. Here it's important to remember the range from -20, the highest priority, to 19, the lowest priority. So, the smaller the number, the higher the priority. The bigger the number, the lower the priority. For example, you can start a command with lower priority like this, nice -n, new priority, for example 10, and your command, ping. And if the process is already running, you can change its priority with renice. I try to show renice 10 -p and here PID, process ID. For the beginning, it is enough to understand this idea. If a process is not urgent and can work quickly in the background, you can give it a lower priority. And one more useful detail. A normal user can increase the nice value, which means make the process more polite. But strongly increasing priority, especially into negative values, usually requires administrator rights. Sometimes you start a command, it runs for a long time, and you realize that you need your terminal back. This is where Ctrl+Z helps. Ctrl+Z does not stop the process completely. It pauses the process. After that, you can send it to the background with this command bg. bg means background, and if later you want to bring it back to the foreground, use fg. fg means foreground. So the idea is Ctrl+Z, pause it. bg, send it to the background. fg, bring it back to the foreground. This is very useful in real work. Let's look at the basic system monitoring. Here, we're interested not only in processes, but also in the general state of Linux, memory, system load, disk, kernel messages, logs. One of the most useful and simple commands is free-h. It shows memory usage. The "-h" option makes the output easier to read in megabytes or gigabytes. Here, beginners are often confused by two things: cache, available. Linux tries to use memory in an official way. If memory is not needed by programs right now, the system may use it as cache to make work faster. So if you see that memory looks used, it does not always mean that something is wrong. It is especially important to look at available. This is the more useful value. How much memory is really still available for new tasks. So the simple idea is, in Linux, used memory is not always a problem. That matters is how much memory is still available. The next command is vmstat. It gives a short summary of the system state, processes, memory, swap, input and output, CPU. For a beginner, it may not look very friendly, and that is normal. At the beginning, you do not need to learn all the columns. It is enough to understand that vmstat is a short general system check. If you want to see live updates, use command vmstat1. Then the data will refresh every second. The commands df and du. Here we will keep it short because we already covered this in lesson 4. df-h shows how much space is used on file system, and du-sh shows the size of a specific folder. In very simple words, df shows how much space is left, du shows what is using that space. Let's look at the general system load. The command uptime. She shows how long the system has been running, how many users are in the system, and load average. Load average is the average system load over the last 1, 5, and 15 minutes. So this is one of the indicators of how busy the system is. If the load stays high for a long time, especially higher than the number of CPU cores, this is a reason to look more closely at the system. At a basic level, the main thing is simply to know where to see it and that this value exists. Very interesting command is dmesg. dmesg. This command shows kernel messages. When it is especially useful, for example, disk problems, USB problems, hardware errors, driver messages, strange things during system boot. So, if the problem is closer to Linux itself, the kernel drivers and hardware, dmesg can help a lot. People often do not read all of it, but instead use something like this, dmesg tail. Yeah, of course. Yep. A lot of interesting information. A very useful command for troubleshooting is journalctl xe. It shows the system journal and often gives hints what went wrong, which service failed, which error was written to the log. If the problem is related to a specific service, you can be even more precise. For example, journalctl new systemd journal d cos sudo. And here it is useful to remember a simple combination. If it is a service and it is not working, first check systemctl status service name, and then, if needed, journalctl -u service name. This is already a very strong base for beginner troubleshooting. So, today we learned the basics of processes in Linux, how to view and manage them, and how to monitor the system with useful commands. We also looked at where to check if something is not working correctly. In the next lesson, we will talk about streams, pipes, and basic text filters. See you in the next lesson.